Hi there, exercise 8 trigonometry here. It's now we're using something called reciprocal functions, and some of the mathematicians I think have seen these before, but the rest of you haven't. So these are the reciprocal functions. One of them is on this. It's called cosec. And so I suppose it's what the hell is cosec? And we're going to look at them and the graphs of them as well. So we've done sine, cos, and tan in the past. These are the standard trig ratios. The reciprocal functions then are 1 divided by them. That's what reciprocal means. It means 1 divided by. So rather than writing sine, I write 1 over sine. And that weirdly is called cosec. I say weirdly because 1 over cos is called sec. In many ways it'd be better if it was the cosec was this one, but it's not. And I do know some people who always look at the third letter. The third letter tells them which one was divided. So cosec comes from sine. Sec gives me a C, which tells me it comes from cos, and cot gives me a T, which gives me a T. So 1 over. So you can see the logic of that. But they're just 3 new functions. What do they look like is really what I'm after. Remember also that tan is sine over cos. So this cot, therefore, can also be written as cos over sine, which is the reciprocal of it. So this is a formula that you need, and these 3 that you need as well. So write them all down. You might want to make a note of the third letter trick to tell you which one's which. Solving them as equations, well, if I got this equation, 3 cot theta, notice it's in radians, so I'll need to make sure of that. But it says 3 cot theta equals 2. So my first job is to write cot theta is 2/3, I suppose. And the fact that it says cot, once I get to the reciprocal function equals, I can just turn it upside down. Tan theta, therefore, is 3 over 2. And now it's just a simple equation. Theta is the inverse tan of 3 over 2, which I have no idea what it is, but I shall do it now. What am I in radians? I'm in radians, that's good. Inverse tan of 3 over 2. And I get a nasty decimal, which is 0.983. Now remember, with tan, you get and the second solution with 180 plus it. Now we're not in degrees, so rather than 180, I'm going to write pi. So basically I have to add pi onto this, so plus pi is 4.12. And it does say initially 4.12, yeah. 3 significant figures. So between 0 and 2 pi, and if I add any more, I think I'll go beyond that. Oh, that interesting. I've got 4.13 there. I disagree with that. I think it's 4.12 if you do it accurately. I think I did use, I'd use my answer button. So anyway, so there's an answer. Here's another one. I'll just delete that off it so I can actually see it. There we go. And this time then it says 5 sec 2 theta. So again, it's the same trick. Start off by writing sec 2 theta is 12/5. And therefore turn it upside down. Remember, sec becomes 1 over cos. So if I 1 over it straight away, I get equals 5/12. Now, there's a temptation to try and think this is double angle formula, which you did last time, but you actually don't need that because I've got an answer here. And it doesn't say do it exactly or anything like that. So I can just write now that 2 theta equals the inverse cos of the 5/12. So let's do that. Now what are we in degrees this time? Oops, drop the calculator. Degrees. So inverse cos, I'll make sure you're in degrees, 5 divided by 12 is 65.4. Well, more precisely, notice I've written 2 theta equals here. And it's 2 theta equals 65.376. I'm going to go one more decimal place. There we go. Now, that's 0 to 360. And notice 2 theta then is really going to go up to 720. So I've got to go quite a long way up. I use cos there. Cos theta gives me another solution at cos of 360 minus it. So if I do 360 minus that, I get 294.62. Yeah, 62. But notice I've got to go up to 720, so I've got to add 360 onto both of these. So add 360 on, I get 654. So I shall leave a gap because I reckon there's one in between. 654.62. And then I've got to add 65 onto that, which I reckon is 425.376. So that's 2 theta, of course. Now I half them all. And halving them all should give me these answers. Interestingly, I've only got 2 answers there. I wonder if I went up far enough on those answers. So if I half that, I get 32.7. Yeah, that sounds about right. That's 147. Now, if I half that, I get 220. So, yeah, so I reckon there are 2 more answers. I think there's a mistake on the PowerPoint. I'll divide that by 2. I get 212. So I reckon I get 212.66, so 213 to 3. Well, it seems to be to 1 dp, so I'll write 212.7. And this last one, 654.62 divided by 2, is 327.3. And again, all of those are under 360, so they're all definitely solutions. I wonder if it was a mistake, but that's the answer to the questions. Now look, here's an identity we saw at year 12. It's cos squared plus sine squared equals 1. And I referred to it when we were looking at double angle formulas or other stuff recently. So now if divide by cos squared theta, cos squared divided by cos squared is 1. Sine squared divided by cos squared is tan squared, and 1 divided by cos squared is sec squared. So this is a new formula we've kind of saw. I remember seeing this on the double angle formula opening slide. It was on the board of Dr. Watson and Sherlock Holmes, if you remember that slide. Now here I've got 1 plus tan squared then equals sec squared. That's the proof of it. And if we divide instead by sine squared, we get a different formula. Cos squared plus 1 equals cosec squared. Now these two formulae, these two identities, you need to write them down, because these are something that we're going to see quite a lot of. Particularly this one, actually. This is the more useful one. 1 plus tan squared is sec squared. This one less so, but yeah, every now and then you need it. So write it down. Now bearing that in mind, I've got an equation here which we might need to be able to solve. 4 sine equals 3 cosec. So let's just write this better. As soon as I see cosec, I think, hang on a bit, that's 3 over sine. Okay, move the sine over. 4 sine squared. In fact, I'm going to move the 4 back again. That gives me equals 3/4. Sine theta is the square root of this. Now, if I do the square root of 3/4, I get root 3 over 2. Not quite. I could get sine theta is minus root 3 over 2. We saw that recently on some of the other questions. So if I do those two things, inverse sine, is it in radians? So make sure you're in radians. Inverse sine of root 3 over 2. This should be an exact answer for obvious reasons. It's a question that we've seen before. So that comes up with 1/3 of pi. Theta is 1/3 of pi. Or, now notice this one, theta equals, so if I had exactly the same thing but with a minus in there, I get minus 1/3 of a pi. Now, bear in mind that it's between 0 and 2 pi. So straight away, I need my formula, which for sine is 180 minus theta, or preferably pi minus theta. So this gives me 2/3 of pi. This one, if I do pi minus a minus, that gives me 4/3 of pi. And notice once you get one answer, you can add 2 pi on. Now that's 6 pi by 3, so I think that gives me 7/3 of pi. And this gives me, I think, 5/3 of pi. Let's see what the answer actually is. Oh, I didn't get 7. Is 7 too big? So I get this. Pi by 3. I get, I don't get this one as well, then that's too high, that's why. I get that one, 4 and 5. And this one is right, but it just goes too far, it goes beyond the range of acceptable values. So this next example then. Now first thoughts here would be perhaps to switch the cosec. And we know, for instance, that cosec is 1 over sine. And we know that cot is cos over sine. Now the first thoughts would be to switch them like this, but in actual fact you get in a real mess. So because there's two of them, I'm not going to go down that road. And instead I'm going to use, remember earlier on I said that there was a formula that basically said that cos squared plus sine squared was 1. But if we divided by cos squared, we got a rule with sec squared out. But if we divide instead by the sine squared, well, he gave you this different formula. Cos over sine is cot. So this is cot squared theta effectively. Sine squared over sine squared is 1. And 1 over sine is cosec. And now I think this is the link between the two. Because it's just, if we went down this road, it would get complicated. So instead of going there, I'm going to say, well, cosec is 1 plus cot squared. So I can say 2 plus 2 cot squared, times them both by 2. And that equals cot theta plus 12. Now you can see straight away that's relatively easy. It's just a disguised quadratic. 2 cot squared theta minus the cot theta. If I move the 12, I think I get minus 10 equals 0. Now that is, as I say, I think relatively straightforward. But if you go down the other road, past experience has taught me that it becomes a mess. So don't go there. So instead I'm going to do this. The polynomial equation of degree 2. So what's my coefficients? I've got 2, I've got negative 1, and I've got negative 10. So I've put those into my quadratic equation solver. And I get the answers. Well, it's 5 over 2, so I can write cot theta. It's 5 over 2. And cot theta is also, just give me, minus 2. Now remember, cot is 1 over tan. So probably it's best to write tan theta is 2/5. And tan theta is minus a half. Notice I've turned both upside down. Solve this, theta equals, I don't think, nice answer, in fact it says 3 significant figures. So back to normal menu, and I'm inverse tan in. Now I'm in degrees, grid it is in degrees, of 2/5, and I get 21.8 degrees. Now a little bit of extra, 8 naught, because I'm going to see if there's extra solutions, and theta on this one is minus a half, so, or tan theta is minus a half, so inverse tan of minus a half is minus 26.57. So just bear that in mind. To get tan, you just add on 180 every time. So 180 onto that is 201.8. It said 3 significant figures, so 202 degrees. Now if I add 180 onto that, plus 180, it's 153 degrees. And if I add 180 onto it again, I've got to go up to 360. I think I can do that. So that's 333. I've lost my pen there. 333. So I think I end up with 4 solutions. I get 21.8. I'll get rid of the naught. 21.8, 202, and those 2. And they look the right answers. So you'll notice what I've done then. I've played around with the reciprocal functions. The 3 main definitions you're going to have to learn. 1, 2, 3. Make sure you've got good notes, and these are all written in them. And then in addition, from the first identity, interestingly, I said we wouldn't end up using this one very much, and then we did prove to actually use it. And then there is this one, which I know we'll use a lot more. But interestingly, in the equation I used, it turned out that we rewrote the cosec as 1 plus cot squared. So have a go at those, and best of luck.